Hi gents, we're going to continue on with coordinate geometry of the circle. This time we're actually going to use a different equation for the circle. So far the one that you've met is x minus h squared plus y minus k squared is equal to r squared. This is when you have a center of h and k and you have a radius of r. This is my favorite one, okay, of the two, and they're both the equivalent of each other. This is the one that I like to use most often because it's just so easy to fill in. You know, if you're given the center and the radius, so easy to fill in. If you're not given the center and the radius, it's not so, if you are given the equation of the line when written like this, also easy. Now, what I said to you was, if you have one like this, don't multiply it out, okay, and I stick by that. I don't think you should multiply it out, but sometimes it's already been multiplied out for you and stuff like that, so you have to be able to deal with it as well. So there's a separate equation of the line. The two things are really just the same as each other, but let me just show you what it is. I'll show you how it's derived. Maybe I'll tell you what it is first and then show you how it's derived. So the first thing is that this new equation that we're going to use, it's not so nice, is when you have a center which is minus g minus f, and when you have a radius equal to, hold your hats, g squared plus f squared minus c. You can already tell why I don't like this thing so much. Then the equation of the circle will be x squared plus y squared plus 2gx plus 2fy plus c equals 0. You can tell why I prefer the one above. It's just much easier to deal with. I'm actually going to show you how we come to this particular thing here. I'll just show you that quickly. If you did have x minus h squared plus y minus k squared equals r squared, I guess you don't really have to know this. You multiply this thing out, you'll get x squared, I'll just do it quickly, plus 2xh plus h squared. I invite you to try that out. Sorry, I should have said minus 2xh plus h squared. And over here, what you will end up getting is you'll end up getting roughly the same, except with y squared minus 2yk plus k squared equals r squared. Now, if we just have a little look at this, if we sort of rewrite this slightly, what would we be saying? We would be saying that x squared plus y squared, there's that bit. We'll call it minus 2hx is what we'll call it. And we'll call it minus 2ky, that's what we'll also call it. And then what we'll do is everything else that is left over, and the bit that is left over is h squared plus k squared. And I'll bring over the r squared as well. Okay, so that's really annoying. That's what we would get if we multiplied out our nice equation that we started with. So this thing and that thing are still the same as each other. So what do we say the center was? We were saying that the center is h and k. Now, if you have a look at it here, we have x squared plus y squared. That's fine, just like we have here. But the value that is in front of x is minus 2 times that value. It's minus 2 times that value. So that's why over here on this side, if you take your x value, if you like, that first one there, minus g, and if you multiply it by minus 2, minus g times minus 2, you do end up with 2g. Just like if you take h and you multiply by minus 2, you would end up with that. Okay, so they are the equivalent of each other. The rest is also true as we go along. The rest is also true. Exact same thing is going to happen here. What would you have to do to go from k to that value? You multiply by minus 2. So to go from minus f to get to that value, you multiply by minus 2. And the last little bit to show you here is, of course, that the bit that's left over, the bit that doesn't have any x's or y's, okay, h squared plus k squared minus r squared, that should equal to this thing over here. That should be equal to c. And if you do h squared plus k squared minus c is equal to r squared, then r will equal to the square root of h squared plus k squared minus c, which is the exact same as what we're dealing with here, except instead of having h and k, we had minus g and minus f. And of course, if that was instead minus g being squared, that's the same as just having g squared. So same with f squared and c. Right, I'm certainly regretting telling you all about that. You don't really need to know that. It's just to show you that it is true. And if you followed all that, fair play to you. But it is not essential to know that in order to be able to use this particular equation here. Okay, so what we're going to do is, just like the last time, we are going to, I'll give you center, I'll give you radius, and we will then go and get this thing here. Okay, so I'll just steal one from your book, I guess. I see one there where it says you have a center of -3, -5, and the radius is root 17. Okay. Well, the first thing is, if that ever comes up in exam, center is that, radius is that, by all means, immediately say, oh yeah, using this thing up here, x plus 3 squared added to y plus 5 squared is equal to r squared root 17 squared, or 17. Done. Get out of there. You're absolutely fine. If they ask you to write it as x squared plus y squared plus some number, we'll say p number of x's plus q number of y's plus another number equal to 0, you should also feel free to do this thing and then just multiply it out. Go x squared plus 6x plus 9 plus y squared plus 10y plus 25 equals 0, and get x squared plus y squared plus 6x plus 10y. And am I missing there? Oh yeah, sorry, it wasn't equal to 0. I'll bring the 17 over, minus 17 equals 0. Okay, so what do we have there? We had a 9, we had a 25, and we were taking away 17, so we were at 17 in that case. There you go, that's what it would be. Okay, so this is the equation of the circle that has center that and radius that. It is the exact same as writing it like that. Okay, except, you know, it just takes a little bit, a few more steps. But this isn't quite the way that they wanted us to do it. So let us do it the other way. You know what, I'll leave that little answer there. We can just compare it at the end, just to show that we also get this. Okay, here it goes. We know that this is the equation. I'm happy to tell you it's in the tables book. So this is minus g, and that is minus f. That's that bit, that's that bit. And the radius here is root 17. Okay, or you can say that also root g squared plus f squared minus c is equal to root 17. We can say that that is true also. Okay, what's the equation of the circle? The equation of the circle is x squared plus y squared plus 2gx. Well, let's see, what do we know? We know that, I'll do it over here. Maybe in fact I'll just do it here. We'll say that it's x squared plus y squared plus 2gx. So we know that minus g from up here, minus g is minus 3, because the center, remember, is minus g minus f. So it turns out that g is equal to 3 and that 2g is equal to 6. Or, so we can say that x squared plus y squared is equal to 2gx, so 2g is 6, so that's 6x. Done. Or what you can do is you can just take that value, multiply it by minus 2, like we said. Simple as that. And you know, you can do the same thing there for this value now, and take that and multiply by minus 2. It's just going to give you 10y. But if you want to do it slowly, that's no problem, especially at the beginning. Minus f equals minus 5. F is 5. And remember, it's x squared plus y squared plus 2gx plus 2fy. So we need to get 2f, and it's that number of y's. Well, 2f is 10, so it's 10 y's. But we already knew that. And then it is plus c equals 0. So this is where we actually have to do a little bit of calculation. We know that root of g squared plus f squared minus c is equal to, we know that is equal to the radius, and we know that the radius is root 17. think about what are we going to do to both sides, and the correct answer is you square them. So we get g squared plus f squared minus c is equal to 17. And remember, we already know what g is. G is 3, so g squared is 9. We already know what f is, it's 25, or so it's 5, so f squared is 25, getting ahead of myself, minus c is equal to 17. So it turns out that 34 minus c is equal to 17. Add c to both sides, he'll be over there, take away 17 from both sides, we get 17 is the c value, so we get plus 17 equals 0 because c is 17, and what do you know, we have ended up with the exact same one there. Now I know that is way tougher than what we've been doing before, and you might say, what on earth is the point of doing that? But the more you do this, the more practice you will get, and it's especially important whenever it goes the other way around. Okay, if you're given the equation of a circle and you want to work backwards. So look, before I do that, what I want to do is I want to give you one to try yourself. Okay, because that was your first time seeing it, so I wasn't expecting you necessarily to pause the video and just go off and give that one a shot there. So let's try one. This one looks tricky. I will actually just go with a tricky one for you to try first of all. We'll say that the center is it says in the book, and I'm just taking this from the book, it's a half minus a half. There's your center, and the radius is root 5, or is root 5. The only thing that I'll write up for you is that generally we talk about minus g minus f being the center, that the radius is the square root of g squared plus f squared minus c, and that the equation of the circle will be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. What I would like you to do is create the equation of a line using the method that I outlined. Don't cheat on this one. I know it's possible to do it. Give it a shot. Okay, so pause me up there and off you go. Okay, here goes. What do we know? We know that minus g is equal to a half, and we know that minus f is equal to minus a half. So it turns out that g is minus a half, and f is plus a half, and 2g, which we're going to need, is minus 1, and 2f, which we're also going to need, is 1. So we can go over here and say that x squared plus y squared plus 2g, that's minus 1x, or just minus x, I guess we'd call it, plus 2f, so that 2f is 1, so plus 1y, we'll just call it y, and then there's a plus c, and we'll figure that out over here. We'll say root 5 equals root of g squared plus f squared minus c. Square both sides. 5 is equal to g squared plus f squared minus c. What is g squared? Well, g is minus a half. G squared minus a half by minus a half is plus a quarter. F is a half, and a half when squared, a half by a half, is also a quarter. And we get minus c there. So what do we have? We have 5 is equal to 2 quarters, that's a half, minus c. So we'll bring c to the left, or we'll add c to both sides, I suppose is the good way to say it, and subtract 5 from both sides. So we get c is equal to minus 4.5, or minus 9 over 2. I think that's probably better to call it that. So c is minus 9 over 2. This would be a fine way to write it. Personally, what I would do, however, is I would multiply everything by 2, and I would get 2x squared plus 2y squared minus 2x plus 2y minus 9 equals 0. I guess they would probably like it written like that. Either one, now that I look at it, actually that one is nicer than the way that I've written it. But either one's good. Hopefully you got that. Takes practice, as I say. It's not the first thing that's going to jump off the page to you. Okay, we're going to make this a long video, and we will look also at when you're given the equation, what can you do? So they've given us the equation here. For instance, x squared plus y squared minus 2x plus 4y minus 4 equals 0. What is the center and the radius of this thing? Now, in this case, this is a very good example where it is actually quite tough to do it with a nice equation. Okay, in fact, so tough that it's totally not worth doing. Now, let's just remind ourselves. The template is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And it turns out that the center is minus g minus f. And that's the center. And the radius is the square root of g squared plus f squared minus c. Let's look at it. What does it turn out? How many x's do we have? Turns out that 2gx's are equal to minus 2x, so the 2g has to equal to minus 2. And it turns out, similarly, that 2f has to equal 4. So we can figure this out. G is minus 1, f is 2, and minus g, the thing that we want, is 1, and minus f is minus 2, just by multiplying both sides by minus 1. So there you have it. You have the center, minus g, which is 1, and minus f, which is minus 2. There's the center. Okay, it's a fast way to go to it. Remember, to go from there to there, you multiply by minus 2. So to come back, you just divide by minus 2. So if you're given this, you can just divide by minus 2. It goes straight there. And you can divide 4 by minus 2 as well. That will get you the answer. We still need to get the radius, but that's fine. It's g squared. So it doesn't matter about the signs here, because once it's squared, it's going to be positive. So 1 when squared, which is 1. F squared, so that's minus 2 when squared. So that's just going to be 4. And minus c. Remember, c is this number here. Be careful. C is 4. So minus c is plus 4. So we get the radius is equal to the square root of 9. The square root of 9 is 3. There we go. We've got our center, 1 minus 2, and we've got our radius, which is 3. Excellent. Okay. I'll give one for you to do now. You can take this as your homework as you do it. Give it a pause as well, and to try and get it. I'm going to pick a tricky one to start off with here. Okay, a tricky one. It's not going to start with x squared, y squared. So don't pause me before I just give you a little nudge to it. It says 9x squared plus 9y squared. Yeah, this is a much tougher one. Minus 6x plus 54y plus 46 equals 0. Yep, 46 equals 0. Okay. The reason that you shouldn't pause the video yet is because, remember, in order to be able to compare it to our x squared plus y squared plus 2gx plus 2fy plus c equals 0, you have to have an x squared and a y squared, and we don't. We have 9x squared, 9y squared. So there is something you must do first before you try this, and it is, of course, since I've nudged you, divide everything or divide both sides by 9. So left hand side becomes x squared plus y squared minus. So this is going to be minus 6 over 9, which is minus 2/3 to my thinking. Minus 2/3 x. 54, when we divide 54 by 9, we get 6, I do believe. So that will be 6y, and this ugly looking thing here, 46 divided by 9. I mean, I'd almost be checking, have I made a mistake here, but I haven't. It's 46 over 9 equals 0. Okay, this is the point now at which it looks just like the one that we did beforehand. What I would like you to do is pause the video. Remember, you're looking for the center, and you are looking for the radius. Best of luck. Okay, here come the answers. Hopefully you really have tried that out. You don't want to just watch me do this. It's tough enough just watching, but you gotta get involved with it. Remember, the center is minus g minus f. The radius is the square root of g squared plus f squared minus c. Here it goes. What do we have? We have the 2g is equal to minus 2/3. Now it's up to you which way you want to go about this. Personally, I'm just dividing it by 2, getting half of it. So if it was 2/3, it'll just be 1/3. It was minus 2/3, so it's minus 1/3, and minus g, the thing I'm after, is 1/3. If you want to, 2g equal, if you find that difficult, if that's not to your liking, multiply both sides by 3. 6g is equal to minus 2. Okay, g is equal to minus 2/6, or g is equal to minus 1/3, as that is, and then minus g itself is 1/3. Okay, so that's perfectly fine. I would have no problem with you doing that. Okay, the next bit is that my 2f is equal to 6, so f is equal to 3, and minus f, the thing that we want, is minus 3. There we go, we have the center. The center is minus g, which is 1/3, minus f, which is minus 3. And now it's just about getting what is the radius. So the radius is equal to the square root of g squared, so that is 1/3 squared, I'll take my time with it, plus f, which is minus 3 squared, I'm just going to call it 3 squared, doesn't matter, plus c, wasn't it? No, minus c, whoops, minus c. So what's c? C is that annoying value there, so minus c is minus 46/9. Oh, how awful. Or is equal to, what's it equal to? Add is going to work out. So 1/3 when squared becomes 1/9, top by top, bottom by bottom, 1 by 1, 3 by 3, plus 9 minus 46/9. So if I've got 1/9 and I'm taking away 46/9, I'll still have my 9, that's that 9, and I'm going to be taking away 45/9. Well, that is a much nicer number to be dealing with. So or is equal to 9 minus 9 divides in there 5 times. That gives us root 4. The radius is 2. There you have it. So that is the center and the radius of that ugly looking equation right there. Okay, gents, that is a lot to take in. I do not expect that to go in all at once. If we were in class, I wouldn't be talking for however long I've been talking for. I'd be getting you to do most of that stuff. So the fact that I'm talking for 22 minutes, I'd be doing this over 2 classes maybe. So what you want to do is you'll want to go back and you want to have a little look at it and you want to retry it and all the rest. Here is what my suggestion is. You want to have a look at exercise 8.3. It's on page 135. And I would try any one that looks scary to you. Okay, from 1 to 20 really is what we've gone and done. Maybe not up to 20, maybe up to 18, sorry, is what I will say. So take any one of those and give it a shot, is what I would say. If you want some vague suggestions, maybe question 2 and question 5 to look like tricky enough ones. We'll say question 12. And I would definitely try 17, actually. I would definitely try 17. So we'll give those for a shot. Your answers are in the back of the book. But any questions on them, please send them to me and I will be happy to steer you in the right direction, or indeed just to make a little video of it. Okay, gents, hopefully you are keeping well. Enjoy the weekend. Take care. All the best.